So what I tell pattern recognition because so previously we had a pattern recognition with soft computing tools. With soft computing tools. With soft computing tools we had. Later part the things as in 15 or 16 the machine learning arises. The machine learning, the course of machine learning has come up. So previously it was with merged with all the tools. We had the soft computing tools with so what is called this fuzzy cultures, neural networks. We had everything in previous part of 10 years. When to 15 the range of people moved to machine learning as a core subject. That's what the computer science and information science got demand because of this machine learning, big data, IoT that will arise in syllabus. That's what the course have been broadened and attracted in various IT companies. So people are attracted towards more on this machine learning concepts. So what is machine learning? That's the main objective. What is the machine learning and why machine learning and why to be needed and what are the things that we can learn in machine learning? That's my entire presentation that contains. So machine learning is about predicting the future based on past. Yes, machine learning is all about predicting a future because machine learning arises from data mining. What I tell, so first we as a computer science engineers, we talks about more about data structures. Then we talks about algorithms. Then we talks about what is database. We talks about finite automata. The course is such a way that it comes with the data mining. So data mining makes the machine learning. That's what I'm talking about. The machine learning is predicting a future, right? It's working on data. If you do the data, automatically we can predict what can happen, especially in the consideration of agriculture. So why I most important because myself thinking about agriculture in the various crops, still I'm not able to predict a good amount for particular crops that have been grown by farmers. So how to predict a market analysis for such a wonderful farmers who grow the various crops? So we need a machine learning. So we need a machine learning where data is provided from all the past 10 years. You want to predict what is happening next 11th year. What may be the crop of 11th year? If I go for any fruits, I may get good rate for this year. Why? Because the machine learning provides that grow this, surely will get a good amount of money. That's what the machine learning is about, predicting a future based on fast data. And even weather prediction. So last year we got a good amount of rain. Maybe this year, sure, we'll get a good amount of rain again. That's what the future prediction can be done using machine learning. So machine learning talks a lot of things. If I tell examples, we have a lot of examples to speak on machine learning. If you go for anything, any analysis, data analysis, because day by day, as you know, data is growing, right? Data is getting, too much of data is growing, especially what the big data arises now. So big data with Hadoop technologies, people are working on parallel processing. So data is coming huge, especially if I go for medical data due to COVID, you can see a lot of patients are reporting to hospital. How to analyze such a huge data? And if I go for customers product analysis, also online marketing. So again, we need a machine learning to analyze what the customer needs all about. Okay, let's talk about the machine learning. So it is vast, it's huge of applications the machine learning contains. With the provision of what you call as data mining, image processing, or a pattern recognition, club together comes with a machine learning. The concept is all about. So it is a computer programs. So learn from experience with respect to some class of tasks and performance measures. So whatever the task assigned by various, if I go to a company, they will assign task. If I work in colleges, surely I will assign task. If a researcher, surely I'll get some task to do. So tasks can be done based on experience. If you have good experience, surely you do wonderful jobs. Again, everything must be measured to performance. If a college consider there is a self-appraisal reports. If a company, again, there's a performance measures for each and every year. There's a performance measures, right? So machine learning talks about the experience. Machine learning talks about the task done by experienced person. Machine learning talks about the performance based on the task and experience can be done. That's the machine learning, which can be useful to measure all the measures to be parameters to be required for a particular person. So machine learning. So machine learning is, think of supervised, unsupervised, and reinforcement learning. So supervised learning talks about classification. So unsupervised learning talks about clustering. Reinforcement talks about the awarded for each agent. So what the award get for each stage of the awards. So our awards we call as especially used for game playing, various game playing teams. So supervised talks about where the teacher teaches subject. For example, myself teaches students. So the students learn from me. Unsupervised learning which talks about teacher without help of learning ourselves. What is clustering? Where the features will be provided automatically, it learns the data grouping. But in supervised learning, it is classification. What the classifiers can do the classification instead of grouping itself. Okay, the class label will be provided for supervised learning, but unsupervised learning talks about the cluster. The clustering, which the features have been grouped automatically. Then there is a reinforcement learning where the game playing most of the things that can be useful for award. For example, rewardness. So for example, if you stage complete one stage, again they will be rewarded. Again, you can go for next stage with a reward. If you want to go back, you can go back and relearn the process, everything. That is called a reinforcement learning. There is a supervised, unsupervised, and reinforcement learning is belong to machine learning. Okay. So one example, credit card analysis. So you can provide credit card or not. You can decide based on the data provided. So there is huge data available. Data is getting too much of data. So you want to analyze the data. So analyze the customer. What is the income of the customer? If it is good, its income, if it's an employer, surely you can provide a credit card or not. So it's automation process which can be done. This is another data where I got from symbolic data. It has a huge parameters. So hospital, a particular city containing various hospitals, the various persons visiting the hospital with almost about 50 parameters. Almost about 50 parameters has been provided for a single, what I call a single person, and 52 attributes you want to clear it out. But thing is, there is data huge. So I taken about 56 samples with 51 samples with the 30 variables. But my question is, if it's easy 51, but if I go for 1,000, if I go for 2,000, if I go for 3,000, if I go for lakh, how to analyze the data? So it's a symbolic data spread, a sample example I given, but if data is getting huge, how to do this one? So that's what we require, a machine learning. Here I take an example, one example I taken, this is a medical woman. There is a medical woman. So the thing is medical. So medical is, I want to first consider about what does it belong to. So it belongs to Y1 or a Y2. So medical woman. So there is a gender called, what do you call it, medical woman. So which is containing weights. So weights of a medical woman. It is represented with almost about 10 to 15 of data provided. If I go for min and max representation, if it is a medical woman data, 73 to 167. So if I go for min max, it is contained 73 to 61, right? So this is min max representation for a huge data. If I go for histogram oriented, I can tell 78, 110 as three persons that belong to in a total number of 14. So 73 to 61, it has 14 data. In that, 3 data belong to 78 to 110. Between 110 to 160, there is 7. 160 to 170, there is a 4. If I analyze there, 50%, again 21%, again 28% can be data can be, this data can be divided. So you can tell that medical woman, 50% of it belong to 8 between 110 to 160. So this is an analysis of a huge data. If I consider I recognize about 50 data, 50 observations, if I think more, surely I can think of like representation based on histogram. This is histogram representation. It's a symbolic representation I given. This is the analysis of a data can be done for a single parameters. Okay. So if I consider types of data, because when I talk about data, I require to understand what is data. So data, there is a lot of types of data available which you want to work. So just now I shown histogram data and interval data. So it is. So if a data gives data, it has single number. For example, height. A person found as height of a person, it is 5.8. If I consider fuzzy, fuzzy means confuseness. Always is confuseness. It talks about around. So if I tell what is the time now, it is almost 11:10. Almost 11:10. So I can round off to 11:15. Maybe it is 11:09, but I round off to 11:10. Right? This is the confuseness that comes around. Interval data, there is a mark between what is your B percentage, what is your MTech percentage. You can tell that between 70 to 75, like that. Histogram data, just now I shown the 3%. This is the histogram data that can be tell that, right? So 3 by 14, 7 by 14. So between this weights, this is can be called as like histogram data. Then we have a multi-dimensional data, which talks about color. If, for example, if what I watch the color like most, I tell red and white, blue. So that it is what I call a red and white and blue. This is a multi-dimensional data. It's called a multi-dimensional data. If I ask my qualification, I will tell that my qualification is BE, MTech, PhD. So it is multi-dimensional data. And there is a dependency data. Dependency means A is depend on B is depend on C is depend on D. Okay. So this dependency, what we talked about in database, that comes with a dependency data. Okay. So crepes, we have fuzzy, we have interval, we have histogram, we have multi-dimensional data. So data is a huge data represented with interval data, work on interval data, classification of interval data, clustering of interval data, multi-dimensional data, representation of multi-dimensional data, clustering of multi-dimensional data. There's a wonderful, what wonderful research can be done, actually, I think of. Okay, so one of our senior research scholar, Bapu B. Karanagi, so he's working on this interval data and multi-dimensional data. I can refer any papers, and even Chidananda Gowda, former VC of Shimoga University, he works on interval data and multi-dimensional data. Even I was working on interval data. So taking interval data and going for clustering and going for classification using symbolic approach that we done with the interval data that can be done. So like that, we can work on multi-dimensional data, we can work on histogram data, we can work on fuzzy data. So various data representation, then go for clustering or a classification. What the representation requires can be done. See, but huge data reduced to a small data, then we're going for classification. It's called reduction and clustering. So that's a wonderful work can be done in machine learning using types of data that can be done. Okay. So features for data which comes with, again, because whatever the things that we consider, we go for features. Because features are the most dominating things, because in machine learning, we talk about data mining with features representation. Okay, so feature as text-based features, visual features. So textual features can be a keywords features, actually, what we talked about text-based. So taking a document, analyze the text, and give a process. So visual features, generally talks about color, texture, domain, specific like shape, and then spatial features. So text-based features talks about keywords. Visual features, what we see. Actually, what we see, that we talks about color and texture. So color feature can be represented with the texture features, various texture features we have. Then we have domain specific like shape. Shape is domain specific because one domain cannot be same with other domain. So shape is entirely different features that to be represented for any object classification or any detection purpose. Because if I work on agriculture, the shape presentation is completely different than when I go for medical data. So medical data representation of shape is different. So that's what I told, domain specific with a spatial and a shape features be represented with the visual features. So this is one of the challenges. So this is a person where one case of detection has been done with a various filtering and various SIFT methods. So this other person who is sleeping but is not able to detect. Okay. So if the person is sleeping, you can see the face expression of the person, and you can go for giving some intimation that this person is sleeping. So this is a face detection algorithm that works very simple way to go for detection purpose with the filtering and what I call as with the SIFT features and go for detection purpose. So this is the challenges that we are regularly we do in a face detection system. This is actually we are in cameras, nowadays iron cameras where our face is automatically detected and automatic enhancement can be done. So that it can be done with the face detection process is going too high in a machine learning process. So multi-class object detection. So this multi-class object classification we can be called as, that's huge. When I talk about learning, because learning is a lot of challenges. It's not easy to learn a simple way. So that's n number of people go for talk about object classification. You can see the object is going up, going on. So object is going on with the classes. So there's animal, there is some devices like devices, there is a vehicle, there is a spoon type of chicken base of things has to be classified. Okay, so classes are going high, with what I call objects have to be classified. Okay, so object has many categories. So many categories. Almost 8 million images has been collected in a real time of data. How to classify this or how to learn this? So because everything is learning, everything is to be recognized, we learn and recognize. So this stuff, this entirely 80 million images is to be recognized is a very difficult task. So our algorithms, what we propose, what we think of, it must be such a wonderful that it's able to learn any of the data that's provided. Okay. So one of the challenges what we face, because I was working in object classification, I was thinking of object recognition. So it is a huge database. Day by day the emails are, day by day the database is growing up. But giving a solution for such a type of data is difficult for us also. Still we are working on. So actually a trend of deep learning nowadays. It's very trending that way we can work with different of technologies that we provided. We can think of giving solutions for such a wonderful problems. So feature types as a color, texture, and shape as discussed previously. So this one example I taken. So one of the fish sorting algorithm. So I want to classify the fish. I want to classify the fishes. So fishes has two types. One is salmon fish and sea bass fish. So it is a camera that provided. It has a camera. It has a want to classify which type of fish in a sorting chamber. So I want to, if I sorting chamber tells that salmon, it go must salmon. If it is sorting base tells the sea bass, automatically it go for sea bass classification. This is one of the examples that we taken for learning purpose. So this is want to learn and classify salmon or a sea bass. So it has various types of features. As I told, features to be required. So I want to learn or classify required features. So features what all the features extracted is length, lightness, width, number of shapes, and a position of mouth. These are the features we extracted for classifying salmon or a sea bass fish. So if I go for fish length as a feature, so fish length as a feature, so 2, 4, 8, 10, and 12, and 14 are a length of the fishes. So it is classified. So 0, 1, 3, 8, 10, and 5, 2, 5, 10, 5, 1 are classified as a salmon fish when length is 2, 4, 8, 10. Okay, so I'll represent this in a graph. Okay, so I'll represent the graph. So now our job is to classify this. So how to classify this? So I'll go for threshold based segmentation, threshold based classification. So if I go for L is equal to 5, so there's 50 samples. When I go for a threshold fixing 5, it comes here, so it automatically classifies that. So it tells that 17 are misclassified. These are the misclassified data. These are the misclassified. Salmon is correctly classified as 2 and 4, 2 and 5. This is misclassified as 0, 1. So 1, 10, 5, 1. 17 by 15, when n is equal to 5, is misclassified error rate. Okay. So if I go for improved version, I'll go for fixing length is 9. And fixing length is 9 here. This part I'll fix. So I'll get about 10 by 50. 10 by 50 is 20% of error rate I got. So this is fixing a threshold. So I cannot fix dynamic. Whenever dynamic data arises, I cannot fix threshold like this. So threshold based of doing classification is very simple way. It's not able to utilize well. That's what I'll go for a representation with what you call as a representation XY data. Okay, XY data. I'll go for representation. If I go for XY data, so this is a representation of features that is XY data can be done. So there is a length and lightness features have been utilized. So length and lightness features have been represented in XY data. So this is the decision boundary. This is the decision boundary effects because there is a threshold based segmentation. Still, I'm getting some errors. That's what I move to XY data. So this is a decision boundary that we have. So I'll go with sample decision boundary. This is a sample that contains salmon. This is a sample that contains sea bass fish. Okay. So as you see, so this is the one misclassified. This is the one misclassified. So data misclassifies is so 2 by 50. So 2 by 50 is 4% of error. Okay. Still I am getting error. So this is threshold based segmentation. This is a threshold based classification. Then I come back with a decision boundary. So still I am getting something error about 4%. But my requirement is to go with a 100%. Right. 100%. So that's what I go with. Instead of decision boundary, I will go with the linear boundary and go with the quadratic boundary. So quadratic boundary look like this. So quadratic boundary, it look like this. So now I have a 0% error rate. Right, 0% error rate. So there is a 4%, there is about 8%, there is about 20%, there is 35%. Now I improved to with a representation of XY data, I will get 0% of classification error. But unfortunately, still I can find some error because of this is static data, it works fine. But if I go for dynamic data, surely this quadratic will not work. Then I have to think about using support vector machine to develop a regression model where it can fix a life based on the features that provided. Okay, the features that provided. That's what the SVM arises. That's what the SVM classification arises with the regression model. Okay, so this is about small classification that I can be shown for a fixed classification model. So other feature I can discuss is local binary pattern. So this time, this is the presentation I goes with the extracting features, how can be utilized, how the feature can be extracted. I'll show everything, every pin off point of each features, because it's very helpful for your research or any of the work your people are doing. So like a local binary pattern, it's the texture features. Which is one of the fantastic texture features we actually using for a lot of classification purpose. So there was a K-bar features, there was a MR filters. So various filters have been provided for classification purpose. In that, we got local binary pattern, local texture patterns, LBPV. So there are various patterns. So various rotation, uniform LBP. So everything are available. Okay. So it's a huge package that contains. So it talks about a center pixel with neighboring pixels. That's what the NP and NC represents. So NP talks about neighboring pixel. NC talks about what you call center pixel with a ratio e to 0 minus 1. If g of x 0 and 1, if less than 0, it's 0. If greater than 0, it is belong to 1. Okay. So I'll take a sample matrix. You can understand this instead of equation in so simple way. It's a 3 into 3 matrix. Center pixel is 4. Okay. So if it is 4 is 4 compares with the 4 is compares with the 3. Okay. So 4 compares with the 3 here. 4 compares with the 3 here. So 4 is greater than 3, right? So that's what is 0. So 4 is less than 7. It is 1. So it is 0 again. It is 0 again. It is 1 because 4 is less than 5. It is 1. So it is greater than 3. It is 0. It is 1. Okay. So this becomes a binary code for a particular 3 into 3 matrix. Okay. Particular code for 3 into 3 matrix. What is next job? Next job I want to represent, right? I want to represent. So I have a bit. So 1, 2, 4, 8, 16, 32, 64, 120 are the bits that to be represented for a LPP model. Okay. So then component is multiplication. So I want to multiply with this matrix with this defined matrix for LPP. Okay. So I come up. So say this. So come up. So what is the question? What I want to do for this? I'll show you what can be done for this. So 128 into 1. So 1 into 2 and 1 into 60. Okay. So next part, I want to sum up all this data. So you can count this. It is 146. It is 146. So 3 into matrix represented with a 146 LBP value. Okay. So 128, 2 plus 16, and count it out. It got it about 146. Okay. 146. So this is the LBP value for this 3 into 3 matrix. Okay. So this is what the LBP works. Hope you can easy to understand this. Very simple way. Still improved version, still I shown different way. See this one again. 6 is a center pixel. You want to compare with 6 is equal. When you go for equalness, you go for 1. If I greater than or less than, you can think of. If it's greater than equal to, you can give it out. So this what 6 is, compare 6, it is 1. Okay, this is the bit represented. This is the threshold can be fixed. This is the weights can be represented. Then come back with solution. See, so 128, 64, 32, 16, and 1. Add this, it becomes 241. It becomes 241 of a computation of LBP. Okay, this is another example that can be shown. Okay, so this is a simple way of computing local binary pattern features. So multi-scale LBP. So we talked about P and R. So P and R with a can be variation between 8, 12, and 16 and 20. So again, rotations 1.5, 2.5, and a 4.0, because rotation radius actually shows that the computation for multi-scale LBP. Okay, so this is the values that can be given. So sample is given. So sample, it can be seen that 70. So 70 center pixel I want to compare with our entire radius of a data. Okay. So 70, so it's, as is shown, is a minus 28, minus 23, minus 19, minus 5. So 70 compares to 0, 8, 13, and 10. So this is the values that can be higher values that can times. This is a negative value, so it is 0. This is positive values that can be 1. It's a negative values, it is positive values, that is 1, because it is represented. If it is greater than, that's what it becomes 1. So now my job is to 1 into 1, 1 into 2, 1 into 4, 1 into 8, next 16, next 32, next 64, next 128. So this is the way representation, because it is a multi-scale. So this 1, so they start with a 1, 2, 4, 8, 16, 32, next 64, next 128, next 128. Okay. So if I add this, because of I add this, I'll get a 15. So this entire sample is go to the value called 15. This is the way of computation for multi-scale LPP. This is computation for multi-scale LPP. Okay. So this is a sample calculation axiom. Okay. Hope it's easy to understand. It's very easy to, because computation is very easy in LPP. So implementation also very easy in LPP. If I go in MATLAB, we'll get a lot of codes. In Python also, we'll get a lot of codes for implementation. This is the way of representation for multi-scale. Then I will go for computation of co-occurrence matrix. So hope you listen or seen GLCM, grayscale co-occurrence matrix. You people are utilized with the various built-in tools that are available. So how to compute co-occurrence matrix? How to compute and co-occurrence matrix? So this is the matrix that is given. So my job is to go with find the number of co-occurrences for this particular matrix. So next, what is this matrix about 4 into 4? So next I want to think about which direction I want to go. Which direction I need to compute the co-occurrence matrix. Okay. So this is the representation for 4 into 4 matrix. So 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 2, 0, next 3, 0. This is the matrix that is built for 4 into 4. Right. So next, you have seen a direction, you have a matrix. So my job is to calculate co-occurrence matrix for this image matrix that is given. Okay. So next, so image matrix we have 0, 0, because the first 4 into 4 matrix is given 0, 0. That is horizontal direction I want to compute. So I need to compute this direction. Okay. So 0, 0. So one time, 0, 0, one time. So there is no other 0, 0, 0. Okay. Right. So because the first matrix had 0, 0. Next 0. Think about 0, 1 for this particular, what do you call, for this matrix. So 0, 1 is, you can see it out. So how many 0, 1 you can find? So you can find 0, 1, 0, 1. That is 2. That is 2. Next I want to come 0, 3. So 0, 1, 0, 2 I want to think about. 0, 2 is this one. It is 1. So I cannot find 0, 3. So 0, 3 is not available in this matrix. That is 0. Okay. So this is the way of computation. This is the way of computation for co-occurrence matrix. So a very simple way to compute the co-occurrence matrix. You can say it out. So this direction 0, 0, 1. So 0, 1. Next 0, 2 I want to think about is a 1. So next entire matrix has been built. Entire matrix has been built for this one. So next you can think about 1, 0. There is no 1, 0 anywhere. So 1, 1, exactly 1, 1 is 2 times. It is this 1, 1 is a 2 times. It is 2. Next I have 2, 2. So it is there 3 times. So 2, 2, 2, 2, 2, 2. It is 3 times. It is 3. Next 3, 3 is 1 time. It is 1. So this is a co-occurrence matrix for this particular image matrix in the horizontal direction. In the horizontal direction. So next I can think about going for other directions. So vertical direction I'm thinking about. So this is again 0, 0, this direction. I'm talking about this direction. So this direction, this direction, this direction. It is 3. Then I want to think about 0, 2. No, 0, 2 is just 0, 1. It's not available because this direction. I'm not talking about this direction. I'm talking about this direction. Next, there is 0, 2. Just about think about 0, 2. You can search it out. So 0, 2, it is available. So like this, you want to build co-occurrence matrix for a given direction. So horizontal, vertical. You can think about n number of 4 to 5 directions, 4 directions that it has. So you can go 4 directions and compute a data. Okay. So this is how you compute the co-occurrence matrix. How you compute the co-occurrence matrix for a given image matrix. But you cannot directly utilize this. So because it's very impossible to use co-occurrence directly because it's not give good classification, right? That's what I want to use second order statistics that you want to compute. You want to go with second order statistics. So second order means second order features you want to compute. That is comes with 11 numeric features that are this. So using what the co-occurrence matrix you compute, Go is computing with entropy features, Go computation with variance features, correlation, what I call sum entropy features, so IDM features, angular secondary moment. So do all this computation for co-occurrence matrix. This makes that completely makes an image features. This makes completely an image features for a particular given image in a data. Okay, in a data. So this is a way of simple co-occurrence matrix computation that can be utilized in any of your tools provided. Because nowadays We learn a lot of tools. It's easy because nowadays we have a good tools. When we are doing PhD, we had only first initially I had what is C++ programming. So initially we had to learn C, then we come back with the C++ Java. Later part we got MATLAB. We got MATLAB when I was 1.5 year completion of PhD. I got R language to learn because my guide was too strict because the supervisor is eager to do means I want to work hard because without my supervisor under my supervisor it's very difficult to do PhD. If you want to work hard, you want to come with want to learn all the technical tools that are available. That's what we learn with the C, then we come back with C++, then we go with the MATLAB, then I come up with R. So after my completion of PhD, Python arrives. So now we need to learn Python because as a teacher, as a professor, as a researcher, for a job to learn, there is some technology that's provided, various tools that is provided. So nowadays, actually Python comes, it's easy to do the implementation compared to what we people are doing. So because of the tools are available, the toolbox are available. If I go for deep learning, I can get entire toolbox. So that's what the trending is changes. So if I got database, surely databases are available. If I want to work on medical image processing, I get entire database in Google itself. So if I want to work on face recognition, I'll entirely work on automated databases. So I want to work on biometrics, surely I'll get a huge database of all the variety multi-model databases. That's what. So database is available. So thing is, pre-processing is available, feature extraction is available, classification is available. So everything is available now. The thing is, you want to think novel algorithm where you can propose and decode all this and come back with a new technology where it to classification or recognition we can do it out. So that's what the machine learning speaks. So it has various algorithms, it has various toolboxes, but our job is to learn this, come back with a good solution, with a novel solution, which can enhance this previous method with your new people method. What a J-bar I call, what David Loy means who's the person who introduced SIFT. But still we people are using SIFT, but we're not able to introduce new algorithms, new descriptors which enhance this SIFT. So SIFT comes with a PCA also. But we want to think about next coming, what can be done after SIFT, improve this SIFT. Still like different way where our name can be introduced in a particular algorithm. Such a way you want to think about while learning this machine learning algorithms. Okay. So this is chain code. This is one of shape presentation. It has 4 connected direction and 8 connected directions. So this is the object that is given. This is the object that is given. So this is the object that is represented like this. So my job is to take this shape and represent with a chain code. Actually, I have 4 neighbors. I have 8 neighbors. So I have 4 neighbors and 8 neighbors. So this is the first representation with the 4 neighbors. First representation with the 4 neighbors. So 0, start with the year 0. Then there is no direction like this. So I want to go with a 3. Okay, I want to go with a 3 because 0, there's no direction, but we have direction here. We have 8 neighbor, a direction, but in unfortunately 4 neighbor, there's no direction for this. That's what 0, 3, 0, 3. Then I come back with, I want to go back for this one because I come back here. I want to go back like this. So that's what it is 0. Next 3, 3, 3. So 3 again, cannot go back directly like this. I want to 2 again 3, right? 2 and a 3 this direction. So this is where like this again you want to represent like this again. So 1 move it. So like this you want to go. Okay. This is the 4 neighborhood representation. This object is represented with this string. This is represented with this string itself. Okay. So if I go for 8 direction, so 0, right? Start with a 0. Next this direction 7 we have. 6, 6, 6, we have a 5 for this direction, again we have a 5, again we have a 3 for this direction, 3, again 2, again 1, again 2, again 1, 2, close. So this is the string with the 8 neighbor. This is a string with the 4 neighbor. So chain code is shape presentation for any object you want to represent. This is a fantastic way to represent to strings through object description and a representation that we have. It's a chain code. Each direction is assigned with a code. So this is the code represent this object for 8 neighbor. This is the code represent for neighbor with a string. Okay. So this is the way of chain code representation done. This is the way of chain code representation done. Very simple way to understand this. Then SIFT, as I told you, not a depth of it for SIFT. So it is a small introduction I'll give it out. So SIFT as input image, you want to consider about difference of Gaussian, you want to build it out. Then you want to detect extremum points. Table, you want to prove the key points. Then a orientation key points. Compute a descriptor for each key points. So come back with this. So this is a small representation of what how shift can be done. So this is the image gradient. So image gradient, what I told, difference of Gaussian, you want to compute out. There's a gradient that represents. So this is the 2 into 2 matrix it contains. Totally, you want to go with 8 orientation. So 1, 2, 3, 4, 8 orientations it has. It has totally a 1, 2, 3, 4. You want to go to 16 cells. 16 cells into 8 orientation does 128 dimension descriptors. So compute an oriented histogram, that is what histogram you want to compute, because this direction it contains. So this direction is what direction it wants, you want to compute. And overall, if you consider for 16 cells, with the 8 orientation it has, it becomes 128 descriptors. That is a SAFT talks about. Okay. Next, I will go with more things about machine learning, because more things machine learning contains KNN, Navi-based classifier, neural network, clustering with K-means clustering, or we have a hierarchical clustering with a partition clustering, which belongs to K-means clustering itself. If I go for classification with a KNN, also again with a simple example. So this is the one of the example I've taken, this height, weight, and t-shirt size. So I want to classify a t-shirt based on height and a weight. Okay. This is a sample I given. This is a sample that we taken with height and weight and t-shirt size. And class level is given. So class level tell that it's a medium, large. So next time if I give a test sample, it must compare with this data and tell that which is it belong to. It belong to medium or it belong to large. Okay. So this distance you want to compute. When you compute with what we call as a training data, this one. Okay. So testing data that we want to provide. So you want to compute the distance between testing and training data. You can use equivalent distance or a Monamish distance or a city block distance. To compute this data with the testing data, you need a distance computation that is done through equivalent distance or a city block distance or a Monamish distance. We have a various distance measures. You can apply this, you can check it out. Okay. So here I am applying equivalent distance to compute the training with the testing data. Okay. So here, so new customer is called Monica, has height of 161 with a weight of 61. So 161 centimeter and weight of 61 kgs. Okay. So now I'll compute 161 and 61 with the first sample of what you call as here 158 and 58 I will compute. So I want to compare 158 with 161, 61. So 161 minus 158 overall equal is a formula of equal distance, the square root of x1, x1, x1 and y1 and x2 and y2. So x1, so this 158 minus 161. So 61 minus 158. So whole cell that appears. So you get a sum distance measure. So you want to do for entire data. You want to do for entire sample of a data of height and weight. Okay. So here I have done a computation for first sample, testing sample with the first sample using equivalent distance. Okay. So this is the computation we done. So this is the distance measure, we got it out. This is the distance measure, we got it out. This is explain and why prove the distance measures can be plotted with the samples. Okay. So you can see this. So K nearest neighbor talks about K nearest neighbor. So you want to compute nearest neighbor, K is equal to, depends upon what you input you provide. There's a lot of research is going on to decide what the K is all about. K is not a what the class people given. So for example, I have n number of classes, K given. If I go for K is equal to 2, if I have 2 classes, because medium and large I have only 2 classes, so I cannot go with the K is equal to 2. So K is depends on the samples or a data set we have contains. Which is still research is going on to define what the K value can be, what is optimal value K can be. Okay. So here I define K is equal to 4 or K is equal to 5 I decide. Okay, I define K is equal to 5. So this is the center that contains 1, 2, 3, 4. This is a sample that given. It contains 1, 2, 3, 4, 5. So this is the distance that compute which is the minimum point that contains, it is 1.4. So this is the minimum computation. It is 160, 60. So class is medium. It is minimum distance, that is 1.4. So after that I have 2.2, 2.2, 2.0, 3.2. So remaining all larger than what I think about. Okay. So 1.2 is 1, as I told. It is 3, it is a 2. So next is 2. Next 2.2 is 3, and it can be 4 or 3. So next one 3.2 is 5. So it is containing when K is equal to 5. I'm talking K is equal to 5. So 1, 2, 3, 4, 5. 5 when K is equal to 5. So it contains 4 as a medium class and 1 as a larger class. It contains 4 as a medium class, 1 as a larger class. So things that what it becomes, so it contains more voting for this medium class and less voting for larger class. So now k, when k is equal to 5, the given sample is belong to medium class. Right? This is the what we call K-name classifier as a voting based classifier. We call it a voting based classifier. If just contain person, if any object contain more voting for this, then you classify this object is belong to this particular class. Okay, so this is see this one. 1, 2, 3, 4 S contains names for this particular class, one this sample to other class. But when I go for voting, when k is equal to 5, if I go for voting, then I can decide that this is a sample which is not belong to second class. So this is a sample which contain more voting for medium class. I can tell this object is belong to what is the sample of Monica is given is 161 and 61 is classified to medium class. It's classified to medium class. That's what simple way of k-means type of classifier can be explained. Okay. So main thing is you want to define that distance computation. So here I define only 2 features. Think about containing more features. Think about containing about 500 features or 1,000 features. Then go for computation. Then see your algorithm how it works. Then see k. Where is the k between what you call as k is equal to 2, k is equal to 3, k is equal to 4, k is equal to 5, k is equal to 10. Check it out how the variable works for each k value. When k is equal to 1, it's called nearest neighbor itself. So go for more than 2 odd values so that you can decide how the k value works and how your algorithm works. I can think of giving a perfect solution for any of the object classification problem. Okay, this is a k-genuine classifier. So that is easy to understand. No assumption of a data can be operated for both classification and regression. Works easily on multi-class problems. Okay, but sensitive to scale of data, you cannot normalize. So you want to think about going data with a normalized data, because when you go for picture extraction, any data can be appeared. It may be negative forms, it may be point-wise data. So various types of data can be arrived. So think about normalizing a data, then go for this classification. And not work for results are not up to like SVM, like deep learning. So very difficult. Results are not up to that. This classification can be about which height of that what the SVM required. So SVM work for a good huge data, but when you go for huge data, it takes a lot of time. The time computation takes is so much of time computation required for this type of classification with the KNN, because there is you want to compute testing with each sample of training. So if I consider about 1,000 training sample, I want to compute with a testing sample, I want to compute the distance between 1,000 samples with one testing sample. It takes a lot of time. So that's what, so before going to KNN, think of and do it out. So make sure that system is fast, that's the way to go for computation. Next one, Navi bias. So before going to Navi bias, I want to know the formula of Bayesian rule. So it is likelihood, so fear and evidence. So what the C containing class, what the X is sample. So it's class containing sample. You want to think about how much probability that the sample contained by class. What is the probability of class and what is the probability of a particular sample? That is called posterior analysis with the Bayesian rule. If I go for Navi bias, this is a product of individual probabilities. It is a product of individual probabilities. That is why X1, X2, X3 belong to class. So X1 is belong to class, X2 is belong to class, and Xn is belong to class. Okay. So I will tell the entire equation. So I will go with a good sample. This is a sample I will do in machine learning classes regularly. Will be take because one of the problem famous is like tennis or not based on the environment that provided. Right? Based on the environment that provided. It has outlook, it has temperature, it has humidity, it has wind, and based on this parameters, you want to tell that the person can play tennis or not. So given a sample, already they given that is when sunny, when out, and the humidity is high, temperature is hot, humidity is high, and wind is weak, we cannot play tennis. So the already label has been given. Our job is to given sample, I want to compute you can play tennis or not. So this is a sample that we consider for a learning Navi-based classifier. Okay. So say this. So overall I have 14 samples. Overall I have D1 to D14. We have 14 samples. So in that 9 samples are yes, correct? 9 samples are yes. And 5 samples are no. 5 samples are no. So we have 4 variables we want to calculate for entire parameters that are contained by outlook, temperature, humidity, and wind. So if I go for outlook, totally sunny has 5 times that appears in a outlook parameter. So sunny has 5 times, overcast has about totally 4 times, rain has about 5 times. So 5 plus 4 plus 5 is 14. So sunny has 2 times. So knowing we cannot play, there is 3. So 2 is S, 4 by 9. Again, is overcast, there is no zero, no, there is no condition of play is equal to S. That's what is 0. So 4 by 9. So rain again 3 by 9, 2 by 5. So 9 is S, 5 is, as I told earlier, it is no. So again, we do for temperature with hot, mild, and cold. So this is the parameters that we got. So this is the humidity in I when normal. So playing tennis S, playing no. So 4 by 5. So again, wind with a strong and weak. So 3 by 9, 6 by 9, 3 by 5, 2 by 5. So this computation has been done. Okay, this computation has been done. So initially data is given. We want to go with the playing tennis. We have 2 labels. There is S or no. We compute 9 by 4. Total number of sample is 14 and 9 with the S and no with the 5 with the total number of sample is 14. Then I go for each parameter that is containing outlook with a sunny, overcast time, temperature, humidity, wind with a strong and weak. So now my job is to tell. So given thing is outlook is sunny, temperature is cool, humidity is high, wind is strong. So you can play tennis or not. So my question is outlook is sunny, temperature is cool, humidity is high, and wind is strong. So I want to question is given, testing sample is given, you want to answer, you can play or a tennis or not. So as I told, outlook is sunny. When sunny is yes, already computed sunny is yes. So 2 by 9 is computed. When sunny is no, 3 by 5. It has been computed. So P is sunny, P of sun, probability of sunny that belongs to class S. So probability of cool, temperature is two things. So cool is 3 by 9. Okay, when no is 1 by 5. So temperature is cool. So humidity is high and wind is strong, belong to class S. Overall sample that contains 9 by 14. So like that for no class, so S is belong to this, no is belong to the probability you want to calculate. Okay. So P of sunny that belong to no, P of cold that belong to no, P of I that belong to no, P of strong that belong to no. Overall, P of play that belong to no, that is 5 by 14, here 9 by 14. P of no is, P of sunny of no is, P of sunny of no is 3 by 5. So do the multiplication of all this, you will get 0.0053 and 0.0206. So it is more value, which is contain more value that automatically that the class belong to. So it is not belong, so it contains the label belong to. You cannot play tennis. You cannot play tennis in this regard for given sample. Okay. So this is the way of computation for Navi bias classifier. It's just product of the sample given. Okay. So which is contain more value, we can tell the class label belong to. Okay. So outlook, temperature, humidity, wind is a sample. This is the way of computation. This is the way of getting the solution. Okay. So hope you understand the KNN well. Hope understand the what you call as Navi bias well. Now I'll go with fast learning neural network. So I'm not able to learn to go for deep learning because it takes a lot of time. If I go for deep learning, I need require 2 hours lecture. So I have actually 1 hour time so that I can go with the basic of what the machine learning requirement, the concern. That's what I'm going with a well-defined problem with a solution also. Instead of telling theory, I think the people will not be much interested. That's what I come with the problems for each and every example that we are providing. Okay. So neural networks, as you know, neural network has input, hidden layer, and output layer. So there is a multi-layer neural network, there is a feedback neural network. So various neural networks are available and we are working on still. This neural motivates to deep learning. So why the deep learning comes? So we want to learn the deep learning with the weights. So because as neural network contain weights, so think about weights and assigning how many layers you require. You can decide the layers. How many layers you require as hidden layer. So how it can be done. What are the weights can be assigned. So everything can be analyzed deeply. Just what deeply. That's what the deep learning neural network arises. Okay. So here we have input, we have hidden, we have output layer. So this is the data that providing. So we will provide 2 inputs, that is 0 or 0 or 0, 1 or a 1, 0. Output must be 0, 1 or 1. If I give the input as a 1, 1, I need to get the output as a 0. So I'm giving input as 1 and 1. Output is 0. Okay. So my question is to input is given. My question is to get a output. So first thing I want to decide weights. So here I had taken a weights. So because assigning a weights and deciding a weights is one of the research process. It's a huge research process. So now I have taken a random values. Just I taken a random values. That's what. So 0.8, 0.4, 0.3, 0.2, 0.9, 0.5, and hidden layer 0.3, 0.5, and a 0.9 has been given. So now I will go with a multiplication. So multiplication of this 3, multiplication of this 3. Okay. So 1 into 3.3, so 0.8, 1 into 0.2, 1 into 0.4 plus 1 into 0.9, 1 into 0.5 plus 1 into 0.3. Totally 0.8, 1.3, and 1 we got presently. So then I want to think about activating this neural network. We have activate functions in the neural networks. So required activate functions. Without activate function, you cannot go for I don't know what to say, activate layers to be cannot be activated. So there is a lot of activity functions. We have one is sigmoid, and this image is not clear. So sigmoid function, we have a linear function, we have hyperbolic function. When a linear I talks about there is a y is equal to x. When sigmoid function I talks about is equal to 1 plus e to the power of minus x. If I go for hyperbolic, again we have e to the power of minus 2x. Okay, so this is hyperbolic that is provided with a sigmoid and a linear. So I want to choose which activation function that's required. So here I will choose a sigmoid function. Here I will choose a sigmoid function that is 1 divided by 1 plus e to the power of minus x. Okay, so now what the values I got? So I got 3 values here, 1, 1.3, 0.8. Now I'll apply this to the sigmoid function that is provided. That is sigmoid function that is provided. That is 1 divided by 1 plus e to the power of minus x. I got 0.73, 0.78, and 0.68. So you can see 0.73, 0.79, and 0.69. Okay. So when you do this, when you do for this for sigmoid function that can be applied for this, we got all these values. So now I want to go with I come to hidden layer. Still I come to hidden layer. Next I need to go for output, right? So say this. So 0.73 into 0.3 plus 0.79 into 0.5 plus 0.69 into 0.9. We got 1.235. We got 1.235. Again apply a sigmoid function. We got 0.77. So my target is 0, but I got is 0.77. Is it nearest? It's nearest to 1, right? It cannot be 0 because if less than 0.5, I can think about it going for target of 0. But now we have 0.77. It is nearest to 1. So what the requirement is target is 0, we not achieved. So what I want to do? Go back to as a feedback neural network. Go back as a feedback neural network, because feedback neural network, go back to first change the weights. So change the weights, check it out. The process repeated. Feedback network is going to go back to this and study this weights. So till you reach a target. Okay. So this is multi-layer because input, hidden, and output. So it's a multi-layer because input, hidden, and output. Go back to the feedback layers. And then think about weights again and come back with a solution. Okay. So this is about a neural network. This is about a sample neural network. I give an example. Okay. So how to build input or hidden layer and output layer. So go with the weights. Use the activation function. What it required. I have 3 activation function. I'm using sigmoid function. So see the sigmoid function 1. So see the target achieved. Otherwise, go for a feedback layer. Go for this. Think about weights again. Come up with a solution it required. Okay. So this is about a classification process that contain. It's about the classification process that contain for a particular process of neural network, Naive Bayes, and K-means classifier. Hope it's easy because hope I made you people to understand. Hope I tried my level best to understand you people. Next, we have clustering. So what is clustering? Clustering is a grouping of objects. So I have n number of people standing here. So we have a lot of people standing here. So what I want to do is I want to group them. So group them. So based on families, I can group them. Maybe male and females, I can group them. So I can group them females and males, I can group them. Okay. So this is the grouping of clusters. So grouping samples based on similarity, is what we can call as. So there's a hierarchical cluster, there's a partition cluster. So hierarchical cluster goes with the bottom to top. Hierarchical partition cluster talks about top to bottom. That is K-means clustering, C-means clustering. We have hierarchical clustering talks about agglomerative clustering, device clustering, which contain single linkage, complete linkage, and average linkage. If I talk about partition clustering, there is talks about K-means and a fuzzy, what we call it, or a C-means, what we call it. Okay, so I will teach single linkage, complete linkage, and average linkage with the partition K-means, that is partition clustering that is called K-means clustering. So this is a sample I taken. So I've taken with the RL Ghosh book. So I have samples, 5 samples containing 2 features, 4,4, 8,4, 15,8, 24,4, 24,5. Okay. So this is the computation I've done between 1 to 1. There's no computation because it's same samples. So there is 2,2, this is not available. So 1,2. 1,1 is 4,4, 8,4. So apply equivalent distance between them. What is 8 minus 4? It is 0. So 4 square. So all of this is 4. Okay. So 16 square root of 16 is 4. So this is the computation that we got between 1, 2. Like that you can do for 1, 3, 1, 4, 1, 5. You get this equivalent distance values that could be measured. Okay. So apply equivalent distance between 1, 2, 1, 3, 1, 4, 1, 5. Like that, because already one has been appeared. Next go for 2, 3, 2, 4, 2, 5, 3, 4, 3, 5, and 4, 5. This appeared. So same matrix have been appeared with the lower dimension with the upper dimensions. So now how to do cluster? I talks about 2 types of clustering. One is hierarchical and partition clustering. So my first initially I'll go with the hierarchical clustering, that with the affirmative clustering, with the device clustering, that is single linkage clustering. So single linkage means first initially I want to identify which is the minimum value that I got from this distance matrix. This is called proximity matrix we call as. This is a proximity matrix that we call as. So this is as a small value, which is the smallest value in this entire matrix, that is 4. So 4 is 1, 2 that contains distance between 1, 2 is minimum distance. I want to merge this. I want to merge this. While merging 1, 2, I am merging this. So you can see it out. 1, 2 I am merging. While merging these 2 samples. While merging these 2 samples, I want to go with a minimum distance. I want to go with a minimum values. Okay. So in this, while merging these 2, 11.7, 8.1, which is minimum 8.1. You can see. When I go for this, 20 and 16, which is minimum 16. When I'm going for this, which is minimum 17.9. When I'm going for this, which is minimum 8.1. Here 16, here 17.9. Like this, we go for merging based on single linkage. So next I will go for next minimum value. What is the next minimum value? Here 4, no 8.1, no 8. So 4, 5, you want to merge with the small values. Okay, so merging this one. Now, which is minimum? So 1, 2 contain 3. So 4, 5, 9.8. So 8.1 is minimum, which is need to go with 3. So 1, 2, 3, and 4, 5. So totally overall merges with 9.8. So you can get it 1, 2, 3. This is dendrogram that represents. So initially merge 1, 2, then we merge 4, 5, then we merge 3 with the 1, 2, then finally we merge entire matrix. Right? So this is a single linkage I done with. Okay, this is single linkage I done with. These are samples. This is the equidistance. This is the way of merging with a minimum value. Overall merging with a minimum value. Total we got entire dendrogram of a single linkage. If I go for what I call as complete linkage of a single linkage or about complete linkage. Here I need to go with the bigger values. Here we was going with smaller values. So a 7.1, 8.1. Now complete linkage I need to go for bigger value, not with a smaller value. Here the bigger value is 11.7. If you want to merge these 2, bigger value is 20. Here is 21.5. See here. I got like this. So next job is check a minimum value, which is minimum 8. So next merge 4, 5. While merging, you want to see it out, which is maximum. While merging these 2, you can see 21.5 is maximum. So 21.5 arises. Okay. So these 2 I merge, these 2 I merge. So later on, I want to compute. So 1, 2 is 7.7, but 4, 5 with a 9.8. So 3 belongs to 4, 5. Okay, this is the one cluster that contains. So previously it belonged to 1, 2, 3. But now complete linkage 3, 4, 5 went out. So this is the one cluster. So 1, 2 first initially merged, next 4, 5, next 3, 4, 5 has been merged. Totally everything merged at a particular point of a data. Okay, particular point of a data. This is a complete linkage clustering. So now average linkage, we call it average linkage clustering. So here first initially anyway 4 is a minimum value, 1, 2 is merged. So while merging, you want to go for average. You want to go for average. If you see this data, 11.4 plus 8.1 divided by 2. So 11.7 plus 8.1 divided by 2. That is 9.9. That is 9.9. So you can add this while merging, add this 2 plus add this 2 and divide by 2. So divide by 2, if we do this, she will get an average value of like this. Then I go for searching minimum value. So minimum is what is the 8. So 4, 5 merge. Later on, so it is 7.7 and 9.8. So 3 merges with a 4.5. So total every value merges with a particular value, that is makes average linkage cluster. Okay. So this is, I'm not able to plot the dendrogram for this. Okay. So I've done a dendrogram for complete and a single linkage clustering. So this is the way of that arises. This is the way of learning clustering with the hierarchical clustering, with the, which is called bottom to top. Bottom to top. So next I'll come with a partition clustering. Partition clustering containing about 8 samples. So that is called with the K-means. So one of the people are nowadays K-means, we're still using K-means. K-means, we have weighted K-means because in K-means choosing a centroid is a really task of research. So when I tell K-nearest neighbor is different. So K-means is clustering. K-nearest neighbor is classification. Okay. So K-means how to do. So K-means choosing a centroid is one of the difficult tasks in K-means because it's a grouping which does it through means based on centroids. Okay. So choosing a centroid is one of the difficult tasks that we are still finding. We have weighted K-means. We have updated weighted K-means. A lot of various K-means have been comes with, and they include with the C-means. They comes with the fuzzy K-means, the fuzzy C-means. So whereas people are going with the different research of areas. So clustering is contained different of areas that contains. Okay. So it has 8 samples. So A1, A2, A3, A4, A5, A6, A7, A8. First, initially I want to choose a centroid. Initially, I want to choose centroid. That is A1, A4, and A7. Okay. So this is time choose. I choose randomly centroids, so not any fix anything. I choose randomly A1, A2, sorry, A4, A7. So this is the distance computation. Again, I'm using what I call as equal distance as a distance measure to compute centroid with the okay. So here A1 is a centroid, which is I told A1 I choose a centroid, A1 I choose a centroid. I want to compute the equal distance between A1. Okay. So A1 I'm computing. So C1, A1 with a C1, A1 with a C2, A1 with C3. So A1 with a C1, that is centroid point that choose 1, that is A1. So this is complete, it is dot with 0. So A1, C2, A1 with a C3. So you can see that it is the minimum value between 3, it is 0. So A1 belongs to cluster 1. Then I go for A2. A2 is to find compute equal distance between A1, A4 and then A7. A1, A4 and then A7. So you can see this. So you can see 5, 4.424, 3.11. This is minimum. That is A2. A2 is minimum. A2 the C3 is minimum. That is belong to cluster 3. So same thing I will apply for A3 with the C1, C2, C3. That is combined minimum value is 2. It belongs to cluster 2. A4. Again it is A4 because A4 is central, I choose it belongs to cluster 2. So like this I want to compute for A5, A6, A7 and then A8. Okay. So I done a computation in equal distance and belong to cluster 5. So now see this. So this is the number people are containing A1. So this is the plot I done for what I call the variables, the samples that avoided. So this is the sample, that is 2. So A1 you can see it out, A2, A7 and A5. So this is one group, this is one group, this is one. So total 3 means, so 3 centered I will choose, so 3 groups and then arrival. So A2, A7, A1, so this is the central point, this is the central what we choose. So this is like this, this is the central can be choose whatever. Okay. So this is the grouping that can be done for a given sample. So now I want to compute the means. As I told, K means. So here I am computing. So C1 contains only one cluster. C2 contains. So now C2 contains 1, 2, 3, 4, 5. So there are 5. So divide by 5 all the samples that contain. So this one. So A3, A4, A5, A6, A8. So add this values, add this values divided by 5. So total we got 5,6. C3 again it does for C3. So 2 variables, so divided by 2. So A2 and A7 contains, so you can see A2 and A2 and A7, 2 plus 4 divided by 2, 5 plus 9, A2. So 2 plus 1, 5 plus 2. 2 plus 1 and 5 plus 2. So you can choose this, so choose this one, 2 plus 1 divided by 2, 5 plus 2 divided by 2, 1.5 and then 3.5. So this is new cluster centroid that arises. This new cluster centroid that arises. Next go for next iteration. Next go for computation of the new centroid point. So now A1 is belong to A8, A4, A6, A5, A3, A2, and A7. So if there is changes within, so there's changes. So A1 is for future 1 cluster. Now with the new SIM card, I got A1 and A8. Okay. So next, go for again K-means. So 3, 9.5, 6.5, 5.25, 1.5, and 3.5 new cluster SIM card that can be chosen. Okay, new cluster point that can be chosen. So now, again, I will do computation. I can see A1, A4, A8 is one cluster, A3, A5, A6 other cluster, A2 and A7 is other cluster. You can do SIM card computation, new SIM card points, until the process there is no such changes in any of the data. Until no changes, repeat the process. Okay, repeat the process. So this is what K-means. This is what K-means. This is first input data, choose a SIM card point, then you can choose, then go for computation, then assign a group, then compute a means, so what go for calculate means, then go for find the SIM card until there is no changes in any of the SIM card values. Okay, so like this, we will partition assembly that is called K-means assembly. It is called K-means class. Okay, like that we have a decision tree. So for example, we do regularly. So this goes out so output is one of the operation that. So this is the entropy we need to calculate because we need to get information for a particular decide the root or the shade of a decision tree. So this is computation, 9 as I told us, 5 as minus. So this is computation I done for entropy. Then I'll go for computation for wind with the weak, wind with the strong. So this is the entropy value I got for information gain value for S comma wind. Okay, S comma wind. S comma wind. Next I'll go with humidity. Next I'll go with computation wind. So I got what I got 0.940 positive values with the positive values and the negative values. So computation is done. So this output is contain more values that I said the root. Then I got sunny or shiny. So I'll go to positive or yes and then again no. So then I want to think about which chapter we need to go. I'll compute again with the sunny humidity. You can see 0.970 and 0.75. So I can see sunny with humidity and the output with the right, the white, strong. So this term differently can be built. Okay. So I have a number like this. So any number of problems we are done, we are one of the problems I felt. So this is one of the problems I like to discuss. This 2D string values. It has a representation left, equal, and a colon. So it does see this is the image represent this to the string. Represent this one to the string. So see this. So this is a mountain, this is a mountain, this is a mountain. It's a mountain with the birds. So M1 and M2 with the birds. So then I have some TV or some donkey or some different objects to get objects CPD I call it. So house 1, house 2. So this is some sandalwood. So 3 and 11. So this one represent left, right, and this one equals and then for the same position. So let's say string. So M1 equals to. I will come to this side. M1 equals to same position, P colon P. Okay, with the same same position, that is equal yes. So go back to left side, to right side is M2, H1 is equal to D. So go back to the centers with the right side, M3 colon same position, M2 colon P is equal to H2 is equal to W. Okay, if I go like this, next one is I go the other way of representation. Yes, and T is equal to T. So this is one way of simple string representation can be done. So it's not here, it's not required, but it is required. Okay, this is one way of representation. So M1, DPD same position, then yes, then right side M2 with H1 and D3. Right side M3 the same position and equal to T, H2 and equal to W. This is a 2D string representation for an image. See, entire image represented a small string representation. Later on, we can use this string with a grammar or evolution or automatic string generation. We can also do it. Think of it going on way of so this is about what we call as my work on machine learning, my way of thinking. So I tried my level best to make people to understand real structure of machine learning. I'm not going with most of the applications because I'm not because people nowadays want to invest in algorithm in parallel. Because instead of going to application, you have a number of applications. Yesterday was before daily session, I was on this time only application part. But this time I decided that going for numerical based testing, very algorithm. Hope is I made it people to understand a little bit of machine learning in this group given class. Thank you so much. Thank you.
Thank you, sir. Thank you for your valuable information with respect to the machine learning introduction and its techniques which has been used within it for providing the information for us. Thank you very much, sir.
Thank you.
Participants, do you have any queries you can ask?
Ma'am, I would like to ask one question.
Yeah, ma'am.
Sir, it was an amazing session. Within 1 hour, you given a lot of information about all the machine learning algorithms. And this LBP, sir, is a weight matrix. Whether it is a standard matrix or we can define our own weight matrix.
Standard matrix.
Okay. So that can we use the standard matrix on all
the boxes of field matrix what the field matrix divide, you can come up on computation.
Okay, sir. Okay.
If you have any queries, even you can put up in the chat box also, participants. Okay, I think no question. Yeah, I think no question, sir.
Okay.
Yeah, thank you, sir. Thank you, Dr. Sharat Kumar Vaid, sir, and I hope participants have got benefit with this session, with the morning session as well as with this session also. I wholeheartedly thank for both the speakers of today's session, and also I thank all the participants for participating in this session. Thank you so much, and feedback link will be shared soon in the group chat box now. Thank you all.